Thank you. Thank you so much for the organizers. Pleasure to be here. So I want to talk about pricing by stake in DeFi insurance, consensus, approach, flaws, and implications. And this is a joint work based on a joint what Rulhan Feng and Mao Li. So I'll skip kind of the motivation because I don't think we need, this crowd needs to be motivated anymore. I'll just say one word that maybe this graph a little bit old, but I will talk about the purple-ish, pinkish, the smaller circle in the middle, the insurance one. I think we have heard a lot of talks about DXs, derivatives, lending, etc., etc. I think this is has not been treated yet. So I'll also, maybe for the sake of time, and I know I'm standing between you and lunch, so I'll skip the literature review, basically saying this is not very new, but this treatment is newer because we want to consider this idea of price formation of insurance claim in a decentralized way, maybe very much related to the concepts of risk sharing and capital allocation. So, without further ado, the big framework is that we'll assume that, talking about insurance, that there is a loss event. Let's call it a set D. And that's going to be a game-based model. So we'll have agents. Each agent we'll assume is endowed with some prior belief. Let's call it probability measure QI. Right, so all agents will agree on the event happening, right? If there is a car loss or some kind of other insurance loss, right? We'll assume that all agents acknowledge that whether it happened or not, right? But they may disagree on the probability of this event happening, right? So each of the small QIs may differ, right? So then each of the agents may decide to stake, to put some skin in the game from their own capital, right? So this is the little, the little xi greater or equal to 0, right? Based on their belief and what is going on right now on the market. And so let's say capital S, calligraphic S, is the total stake of all the agents in the market, right? Then the price given to the insurance buyer is going to be given as a function P of this S. And this function will satisfy some assumptions. For example, we'll assume that if the claim happens, then the insurance will have to pay 1 unit. In that case, otherwise it pays 0. And so, for example, P should be decreasing as a function of S. The more people stake, the cheaper the price should be. It should be bound by 1. The price should not be greater than the maximum loss, right? And then ultimately, if there is no claim, then the agents will get to distribute the premium, which is P of S, right, among themselves. For example, based on proportionally to their stake, right? And otherwise, if there is a loss, then they will take a loss of 1, right? But they will still get the premium, get to keep the premium P, right? So the loss is going to be 1. The total loss is going to be 1 minus P, again distributed between the agents. And so each agent, given that knowledge, right, each agent will try to maximize his or her stake, right, based on the profit, the resulting profits. Now, so we'll try to make it general, but there is an actual usage in mind, right? So this is the model formerly used by Nexus Mutual, right? So they used this pricing function P, right? And importantly, there is this parameter mu that I'll be very interested in, right? So this is the optimization for each of the agent, right? So each of the agents assume is endowed with its own separate utility. UI, nice, concave, continuous, and having some initial capital CI, right? And so then the agent is a maximizer of the utility, right, based on the capital that it will end up with, right? It always gets the premium P, right? It may or may not have to take the loss from paying out the claim, right? And multiplied by the agent's stake, the ratio xi over s, right? That's the proportional stake of the agent I. So we'll analyze two settings. They happen to be two extreme settings. One is, we can think of basically that each agent has no information whatsoever about the other agents, the false consensus setting, when each agent will just assume that from not knowing anything else, it will believe that all other agents share its belief identically. And the other extreme is full information, and this is the Nash equilibrium, where every agent knows everything else about what the other agents are doing, right? And that's the full information setting. So let's consider the false consensus setting first, right? So again, each agent not knowing and not having any other information about any other agents assumes that they're all identical and that they're identical copies of himself. Right, so same prior belief, same utility, same initial capital, same everything, right? These beliefs are not necessarily true, but will help us to actually be able to do computations. So under some assumptions that I'll point out that the next neutral pricing function does satisfy, we get the main result that number one, in the false consensus setting, right, all agents will stake, right, and that's the stake xi hat. So these are strictly greater than 0. From the agents, from the every agent I perspective, the price behaves rationally. So ultimately, it's going to be very close to the probability of the default qi. Right? Unfortunately, we don't have a very good and somehow a desired bound that the market is rational. Rather, the price will always be less than or equal than the rational, the true rational choice of the market. We can actually calculate explicitly things into simple cases. Right? Number one is the first case. That's the risk-neutral utility. Right, in this case, first, we observe that as the number of agents increases, then everyone's stake will decrease to 0. Number two, the stake is inversely proportional to the probability qi. The greater the probability qi, the less the agent I will stake. From the second equation, we can also see that if this parameter nu from the pricing function is equal to 1, then in that case, we can show that the price will converge to the true price, the average belief of the agents as n goes to infinity. The number of agents goes to infinity. And then very similar conclusions hold in the second case where agents are risk averse. And in that case, we can also see that as the risk aversion increases, then the price will decrease. The price will increase as expected. So this is the false consensus. So again, unfortunately, in general case, we do get that from agent I perspective, the price is rational, but we do not get that the market as a whole acts rationally. So the other case is the full information. That's the Nash equilibrium case. Right, so as a quick reminder, right, a Nash equilibrium is given the GI, the third bullet point, the agent I preferences, right, over all the possible strategies. Nash equilibrium X star is when agent I cannot unilaterally deviate from the strategy X star, right, by gaining. Right? So that X star is the best strategy, or at least is one of the best strategies for agent I. So again, we have some assumptions on the pricing function, but in those assumptions, right, we have that number one, Nash equilibrium exists and unique, right? And number two, everything is a function of the total stake S star, right? And specifically, we get that agent I will stake xi star is greater than 0 if and only if the price of the total stake, the P of S star, is strictly greater than the agent I believe on the default probability Qi. So some properties, right, kind of as naturally expected, right? If we increase Qi while keeping all the other quantities the same, everything will decrease, right? Agent I stake, the total stake, the proportion of agents I stake, all of those will decrease as expected. Agents I becomes more risk averse. Number two, right, we get that if you change agent I utility, right, increase the absolute risk aversion of agent I, right, then everything will decrease as well. Right, and then interestingly, if you keep the state the same, but will add an extra agent to the system, so let's say n+1 agent, right, then the total stake will actually increase. To differentiate it with this with the false consensus, right, with no information, not all agents will stake, right? They will only stake if the third condition was met, right? We have that the stakes will decrease, right, as the probability of default increases, right, and then the stake will increase as risk aversion decreases, so agents become more and more risky. So to illustrate this, so we have some synthetic data, right, with the following parameters that we chose. Right, most maybe importantly is the last bit, that we assume that all that the agents will have uniform probability of default, right, around the true probability of default 0.5. Okay, so the first case is the Nash equilibrium case, right? So in this case, you can see from left to right, right, that the risk aversion gamma rises, right? In this case, as expected, right, the price will increase, right? And this is one of the cases. This is one of the parameters that can make it or break it, whether the market is going to be sustainable or not, right? The true price is again 0.5, right? So if the agents are are not sufficiently risk averse, right? Too much risk seeking, then this market will ultimately fail because the price is going to be way too low, right? As expected, number of agents will increase, right? And the total stake will decrease, right? So the second is natural, right? More risk averse agents will stake less, have a decrease in total stake, but the number of agents will actually increase because from each agent perspective, right, there is less total stake, so it incentivizes more and more agents to stake something, right, while at the same time, again, the total stake will still decrease. All right. In the other case, again, in the Nash equilibrium, right, if we tweak this new parameter, right, as we increase it, again, in this case, the number of agents will increase, and so does the total stake, right, because we're not changing their risk aversion. We're only changing the sensitivity of the price as a function of the total stake, right? So the total stake will increase, while at the same time the price will increase. So again, this is one of these variables that will make it or break it will make it or break it in the sense of whether the market will become sustainable or not. Here is the second case. This is the false consensus case, right? In this case, as opposed to the Nash equilibrium case, all agents will stake. Everybody stakes, right? So the number of agents is always 60, right? But if we tweak the parameter nu, right, from the price function, right, we see that again the price will rise, right, and as well as the total stake, right. And then lastly, in the false consensus, as we change the risk aversion case, right? Again, all agents will stake in all the cases, but as risk aversion increases, as expected, right? Not surprisingly, the total stake will tank, right? And therefore, the price will increase. And again, that's the parameter that will make it or break it, right? Between what the market will be sustainable or the price will be too low. So in conclusion, DeFi is very good. It's a very interesting topic to also analyze these price formations. In this case, we did it for insurance, right? And we've considered these two cases, the false consensus and the Nash equilibrium, right? And analyzed, right, to see something whether the market will be sustainable or not. All right, thank you for your time.
Any questions?
Thank you for your presentation. I'm Anton, and I would like to ask a question. Can you provide some examples of using insurance in DeFi?
So Nexus Mutual has actually product running. So these are kind of DeFi product. I believe they are kind of also geared towards DeFi. So they're based on basically events on the chain, things being hacked or things like that.
Yes, but is it insurance of something like real cases in real life, or is it insurance of, I don't know, of hack of protocol, of losing money?
The latter, yeah. So it's protocol-based insurance, yes. Mm-hmm.
And all insurance are based on long series of data for years. And there is no such series of data in such case because it is very new. How can they count the probabilities?
Yeah, that's a very good question. So one part that I didn't talk at all about is how do the agents basically go and estimate, right, and how the claims are actually settled, right? I assume that everybody will agree whether the claim happened or not, and there is an insurance event, but even that is not the case, right? So number one, that's why it's decentralized. So basically, it's up to the agents to somehow figure out the probability. Right, and which is why I think there was a very interesting question in this case, whether the market will get ruined or not, if it's sustainable, right? But yeah, there's absolutely not enough data. There's very little data.
Thank you. Any other questions?
I just had a question about the first result that you showed, and then you said kind of that it's rational for the participants, but not, like the price is rational for the participants, but not the market. I didn't quite get what that like means.
So basically, like in all of these results, right, you want ideally the price to be 0.5, right? That's the rational price. That's the true price for the insurance, right? Because we assumed in all of these cases that the claim happens exactly with probability half, right? So if the price is way too low, then the market will basically, it's very good for the insurance holder, right? Because the price is low, but the market is not sustainable because the assumption is basically everybody will get ruined. Versus if the price is too high, well, that's great for the providers, right, of the insurance, but not so great for the insurance holder.
So when is the market not sustainable? Does it like depend on the risk averseness of the liquidity providers?
Yeah, exactly. So it depends really on the model parameters, right? So if in this slide, if nu is too high, right, the pricing function has the parameter too high, then the market becomes not sustainable, right? I think in one of the previous slides, if let's say in this case, right, if gamma is too high, then again the same result holds, right? The market is just not rational, right? But if the gamma is too low, then the price is too low, right? 0.3, 30 cents, and then the market is just not sustainable.
Yeah, just more a comment on the previous question. So if you look at Maxim Mutual, most of the contracts are very short term, so 4 weeks, 6 week max. So I think this is partially a reflection of the fact that there is no longer term history. So agents feel comfortable assessing risk for very short periods of time, but not over longer time horizons.
Right, yeah. Thank you. Mhm.
Okay, great. Yeah, thanks for everybody coming to the session. Please give this to the other round of applause.